Hi dear. So last class we have seen the one of the chemical produced with the help of the sodium chloride, common salt, right? NaCl plus H2O gives NaOH plus Cl2 plus H2 gas, right? So we have so many uses of NaOH, Cl2 and H2 have been discussed, right? Seen, right? So today we'll see two more important chemicals produced from the NaCl as a raw material. Okay, so we are going to see the bleaching powder and baking soda today. Okay, so we have seen that when NaCl reacts with water to form NaOH plus Cl2 and plus H2, right? That Cl2, whatever the Cl2, the chlorine gas is produced, right? That helps in the production of this bleaching powder. Okay, bleaching powder. The common name used for this chemical is bleaching powder, and the chemical name is calcium hypochlorite. Okay, this is a chemical formula. CaOCl2, calcium hypochlorite. Okay, this is a some people will say calcium oxychlorite also, but as per IUPAC naming system, it has to be called as calcium hypochlorite. Okay. It is produced by the action of chlorine on dry slaked lime. Okay, dry slaked lime. When chlorine gases pass over the dry slaked lime, okay, you will get a calcium hypochlorite. Okay, sodium hydroxide. Slaked lime. What is the chemical formula of slaked lime? CaOH twice. Sodium. So calcium hydroxide, right? CaOH twice. Calcium hydroxide plus Cl2. That is chlorine gas gives CaOCl2. So calcium hypochlorite plus H2O. This is your bleaching powder. Okay. The chemical name is calcium hypochlorite. Okay. Next, the uses of this bleaching powder. You know that it is bleaching means that is your whitening agent, right? So main use is that for bleaching cotton and linen in the textile industry. Okay, so whitening purpose. Okay, for bleaching the cotton and linen in the textile industry. Likewise for bleaching wood pulp in the paper factories. Okay, the paper is made from the fibers, right? Plants, right? But it is not white in color, but still we are getting a white papers, right? Notebooks, right? So how it happens? By bleaching of the wood pulp with this powder. Okay, bleaching powder. Okay, next, for bleaching washed clothes in the laundry they use this bleaching powder for whitening the dresses. Okay, for bleaching washed clothes in the laundry, and it is used as an oxidizing agent in many chemical industries. Okay, it is used as an oxidizing agent. Okay, then to make drinking water free from germs. To make drinking water, chlorine usually at the end of the water treatment process, the uses of chlorine also we are saying it is used in the water treatment or disinfection purposes, right? In the end of the water treatment process, always it is disinfected by passing the chlorine gas. They will put the bleaching powder. Okay, or they can use the chlorine gas. Okay, to make the drinking water free from the germs. In the maximum of the public water uses, public waters, they use this in the water tanks, wells, and the toilets. They use the bleaching powder to make drinking water free from germs. Okay, so this is the one of the byproduct of, one of the chemical product formed with the help of a common salt, sodium chloride. Okay, and next we now move on to baking soda. Baking soda, that is familiar for you, as used in your home, right? Common name is baking soda, and the chemical name of this baking soda is sodium hydrogen carbonate. Sodium hydrogen carbonate, NaHCO3. Okay, how it is formed? When NaCl reacts with ammonium in the presence of water and carbon dioxide. Okay, NaCl plus water plus carbon dioxide plus ammonia gives sodium hydrogen carbonate plus ammonium chloride. Chloride. So this is where sodium hydrogen carbonate. This is where baking soda. Okay, in NaCl plus H2O plus CO2 plus NH3 gives sodium hydrogen carbonate and ammonium chloride. Next, ammonium hydrogen carbonate is a mild non-corrosive basic salt. Okay, it is also a type of salt, but what will be the pH of the salt? Slightly greater than 7. That's why it is called basic salt. Okay, it is non-corrosive in nature. Usually the bases are very corrosive in nature, but this is slightly greater than 7. That is it is non-corrosive. Okay, this is used for the cooking purpose, right? On heating NaHCO3 while cooking, it becomes sodium carbonate. NaHCO3 on heating, it becomes sodium carbonates plus water plus CO2. Okay, this is your sodium carbonate. Okay, you see uses of baking soda. Okay, baking soda. Okay, it is used in kitchen for making crispy items. Okay, they used for give the crispiness for the some snacks items. Okay, it is used in kitchen for making crispy items. It is sometimes added for faster cooking. For fast cooking purpose, they will add this baking soda. And for making baking powder, okay, slight difference between this only. Okay, for making baking powder is a mixture of sodium hydrogen carbonate, that is your baking soda and mild edible acid, example tartaric acid. Is an acid, natural acid present in tamarind, right? For making baking powder. Okay, what happened to this is, upon heating or mixed with water, the following reaction takes place. NaHCO3 plus any acid, hydrogen ion plus from any acid. Okay, it forms carbon dioxide gas plus H2O. Okay, this the carbon dioxide, main ingredient produced, right, makes the cake or bread to rise. Okay, and making them very soft and spongy. Okay, so and you will get a sodium salt of acid. For example, if you add acetic acid, means it will take the H plus ion. Okay, ions from that acid. Okay, and it produces sodium acetate. Okay, sodium salt of acid. Okay, the CO2 produced in the above reaction cause bread or cake to rise, making them soft and spongy. Okay, and also since it is somewhat alkaline in nature, it is used in antacids. Usually milk of magnesia is used as a antacids, but here this is also used as a antacid. Okay, because it is a non-corrosive basic salt. Okay, it is used in antacids. It neutralizes excess acid in the stomach and provides relief. Okay, and also it is used in the soda acid fire extinguisher. In the fire extinguisher used in the home, they are using this NaHCO3. Okay, the soda used is your NaHCO3 baking soda, and acid should be your sulfuric acid for fire extinguisher. Okay, so the mainly it is used in the kitchen for cooking purposes, to make the cooking faster and crispy and tasty things, and also for making a soft and spongy cake and bread, and it is used as antacids and also used in the fire extinguisher. Okay, soda acid fire extinguisher. Thank you.